Right. Hello, everyone. Hello, Bongamusa. Hello, Suleiman. Hope you're doing well today. It's Wednesday. It's Wednesday of week 5. Hello, David. Hello, Dirige. Hello to the Gonzo. I'm assuming that's short for something, or what do you all want to talk about today? Keep in mind, I'm not going to start talking about the DW Mini project until next week. So I want to give you all a chance to read or work through the basic material about pandas first. Let's remind myself what's in the DS Basic DS Modules notebook. It's mostly a listing of modules which are useful to know about. Matplotlib, pandas. Oh, I must be thinking of this other notebook that matplotlib fraction. Hello, Babatunde. As I said, is there anything that you guys in particular want to talk about today? I have come here with no particular agenda in mind. I could find something to talk about if you guys don't have any questions. But, it would probably be better if I talked about things that you guys had questions on. What is the purpose of this? That is a terminal command. Script anomalies. I think script anomalies was in the DW Mini project. As I said, I'm not discussing the DW Mini project this week. It'll be next week. So the cat command is a terminal command. The cat command is just, I don't think we have the manual pages installed. Yeah. So the cat command is just a way of printing a file to a screen, more or less. Which notebook did you find that command in? I can't remember. Bong Musa. Right, so I guess you encountered this in a Jupyter notebook. So yeah, it's a terminal command to basically print out a file or part of a file. So like DS IO or DS pandas. Right, as I said, the exclamation point is turning this into a cell to run some command from the operating system. Right, so yeah, this right here, is basically printing out the information that's in this file. Cat command is kind of short for concatenate. So yeah, this is just to show what is in this file. So ls data like cat data CSV sample text will just basically print this information in this file to the screen. Shushma, what do you mean it is not working for me? I don't know what it is referring to. Note when I'm using this command in the terminal window, I'm not using an exclamation point before the cat command. It's just CAT, no exclamation point. The exclamation point is in here because that's telling Jupyter that this is a command that should be run in the terminal. But the output shown here to this Jupyter notebook. It's also not going to work unless you actually create this file. What other questions do you guys have for me? Again, Shushma, I don't know how I could help you without some more information. Something's not working, well, that could mean, or something went wrong, that could mean a lot of things. I would need more information to try and help out. So yeah, hopefully you guys have got into the pandas material, right? Pandas is one of the more useful tools that's available for data wrangling. Please give more insight on the lambda syntax. I do not understand its concept. All right, I can try to do so. Let's create a new Python file. So, right, the lambda is just a way of defining a function. So, all right, I'm surprised there's no help here. So this syntax right here allows me to define a function. Generally, the idea is these functions are relatively simple. Here I take one input and I provide one output. Of course, I might provide, maybe I provide a tuple as output. So, right, I could use this lambda syntax right here. Again, this will define a function. This finds a function of one variable. I'm choosing to call that variable x. I could use any variable name I want right here. I can make another lambda function. Let's spell lambda correct right here. So my variable I will call x, y, z. And I will compute the value of 2 times x, y, z plus 10. So I've defined two functions, each of which will take one input. So g of 10 will give me the value 30. Right, so this is just a way of defining a function in Python. So here, so again, for a single variable, lambda x, y, z, and I have a colon, and then I have some function that I want to, to apply to return using this variable x, y, z. I could also use this to define a function of, say, two variables. I could just as easily supply a function h of 0 and 12. Well, 0 times 12 plus 0 plus 12 gives me 12. H of 1 and 12 gives me 1 times 12 plus 1 plus 12 gives me 25. So again, the syntax is just, it's this keyword lambda. I could have one or more variables separated by commas. And usually it's just a kind of simple mathematical formula that I might want to compute. Although I could certainly, let's define yet one more function, lambda, a variable I will call 3t's for no particular reason. Let's return a list of range from 1 to t plus 1. So m of 5 will give me a list of the numbers 1 to 5, whereas m of 10, parentheses will give me a list 1 to 10. m of 0 will give me an empty list. I basically, the general idea is that I can't have anything which is too complicated right here in my function definition. So typically these are short functions. They're usually short functions that we want to use in some other setting. Like if we are using the sorted method to sort a list of some objects, and I want to specify how those objects should be sorted. What is the key that I want to use to sort the objects in the list? So it could be a function of 1 variable, 2 variables, 3 variables, however many variables you like. Typically, we're usually going to see them in a single variable or maybe a pair of variables. Although again, there's no restriction inherently on the number of variables that you could use. So I have lambda x colon and then or xy here and then some function. In fact, I don't even, let's try to not confuse things by pointing out special cases, right? But it's just a way of defining a function. Here, each of these functions I'm defining, I'm assigning to a variable name, which again, I'm just using a single letter. This doesn't have to be a single letter. Right? What is the type of this variable? This is a function. This is a function that takes 2 arguments. It will be an error if I tried to call this function with a single argument. Right, missing one required positional argument, namely y. So I've defined my function that takes 2 arguments. I need to specify 2 arguments right here. And this function is taking my two numbers and multiplying, and then adding and adding to return this number. So again, lambda, the keyword lambda is used to define a function. As I said, usually these are short functions that we may only want to use in, one line of code elsewhere. So is this helping, David? Am I making things a little more clear here? Again, each of these functions I've assigned to a name so that then I could call this function with different arguments. Right, this value here, m, so this variable ttt takes on the value of this number inside parentheses. And so, well, we want to create this range. We pass this to the list function to actually return the list of values in this case. This is going to be, I'm assuming that the user is going to give me an integer as input for this function. There's no type checking that's going on. Right, if I supply a floating point number here, I'm going to get an error because the range function, the range method right here is assuming integer values for inputs. And yeah, so I say these are often short functions that we use to define to use in, some other setting. Like I was doing yesterday in the day before. Time has no meaning to me at the moment. Right, the sorted method here, I want to sort a list. I'm using this lambda function to tell Python how I want to sort the elements in this list, right? Pull out the value of name in this dictionary, use this value of name to sort these items. Here I'm saying, well, look at this tuple. I want to treat this dictionary as if it was a tuple. Sort values, treat it as if it was a tuple with the first value being name and the second element in the tuple being the value of stuff from this dictionary, and so on. So again, this is a common location where we might use a lambda function. We use lambda function when it's short. Otherwise, use a regular def, yeah. Or like this kind of situation, like I typically wouldn't want to bother defining this function because like I'm only using this function right here in this method to sort this list. If I wanted to, I could, so let me run this code. I could define a function. I could I could say, well, def get tuple. I could say, well, return x name x stuff. Oops, let's close my brackets properly. I could I could define this function and return the tuple, and for my key, I could supply the name of a function. Right? Maybe if I have some very complicated kind of data structure, maybe I need some function which will define some fancy, ordering. Right? But again, I could supply the name of a function right here, a function I've defined, in the traditional fashion. And Python will use this to, again, sort this list of dictionaries. That's perfectly valid. Maybe I've defined this function previously for some reason or another, and well, I'll just recycle that function right here in this sort method. But yeah, typically lambda functions are pretty short in nature. They're typically used in this kind of one-off situation, right? I want to sort this list. Oh, all right, how do I want to treat these values? They might often be used in a situation when I want to use the map method. If you've not seen the map method, it's worthwhile. You say, all right, I want to say map. I'll take, say, again, a lambda function, usually is what I might use here. The map right here gives me a generator, right? I want to apply this function to every element in this iterator. I could wrap list around this, but usually I don't want to do this, right? I might want to use like this map in a for loop. For I in map, print I could use this map in a for loop, and the benefit of the map method is that it's implemented as a Python generator. If you're not aware of Python generators, they are good things to know about. A lot of things in Python are implemented as generators. Let me see, can I find my Python, sorry, Python generator. I think this is the best, yeah. If you don't know about generators, they are useful to learn about. A Python generator is much like a function. Define a function. Well, usual definition of, let's say, Fibonacci. Fn-1, Fn is 0, 1. While true, return fn, not return, yield fn, fn minus 1 fn is equal to fn, fn minus 1 plus fn. This right here, it looks like a regular definition of a Python function, but instead of return, I've used this word yield. This makes this into a Python generator. This is a Python generator. Again, the yield keyword is what makes this a generator. Now, what does this mean? Let's say I create an instance of this generator. Let's say type of fib is a Python generator. I could use this with the next method. I say next fib, next fib, next fib, next fib, next fib, next fib. Right, the idea here is I create an instance of this generator. When I supply this generator to the next method, what happens? Well, the first time through, Python will start at the top here and it will execute this code. So it'll set this variable equal to 0 and set this variable equal to 1. And we enter this loop. This loop is basically an infinite loop. Right? While true, this will always evaluate to true. What does the yield method do? Well, yield acts like return in that this function will, or this generator will give this value 1, and then this generator stops. However, this generator has what we might think of as some persistence of memory. What happens is when next is called on this generator picks up the line of code after the yield statement. Right? This like remembers where it was. Right, this yield statement was executed. The value, the current value of this variable was given back. And again, when we call next, well, this generator remembers, hey, and it picks up and it executes this next line of code. So it will compute these variables, and then we will return to the top of this while statement and say, well, is this condition true? Yes. Then it will execute this yield statement. So we'll get a value back, and then the generator stops. Right, so again, this next method will find and generate the next element in my sequence of Fibonacci numbers. Right, 8 plus 13 is 21, 21 plus 13 is 34, 21 and 34 is 55, etc. So again, this is a generator. This will, in principle, generate as many Fibonacci numbers as I want, one at a time. Well, I could keep on going, in theory, forever and ever and ever and ever until I run out of memory in my computer. right? So as I said, the yield keyword turns this function into a generator. And generators are used a lot in Python. You know, we may not know that something is a generator, but they're useful. They allow lots of functionality. And they have this persistence of memory. Could I better explain question 2b in the PW mini project? Is this the output of the groups? Yeah. So let's go here to data wrangling and mini projects, and so the idea here is as follows. Let's find my create a new board. So the idea is as follows. We have the input right here is going to be a list of dictionaries. So these are dictionaries. So the idea here is, so we have a list of dictionaries. So each dictionary here in this list has a key, which is this BNF name, for example. And each dictionary has a postcode. So the idea here is, so suppose we want to group by this tuple BNF name and postcode. Right, so we want to group by a tuple of values. Now, what does this mean? So in our group by, we had group by, what were we calling this? I think we're calling it group by field. Or group by fields, but it's group by field. So the idea, the output, is a dictionary. So the output of this function is a dictionary. What are the keys? The keys are these different tuples for BNF name and postcode. Right, where this BNF name is over all possible BNF names in our drugs. So, right, I'm just going to simplify, right? I might have a drug. So this is some drug A as a string, and my postcode CV17AL. Right, this is one of my keys in my dictionary right here. I might have a drug B. and maybe the same postcode, CV17AL. Right, this is another key in my dictionary. I might have a drug A with some other postcode, L15BN. Right, so the keys in this dictionary are all tuples of this form. So for all possible BNF names and all possible postcodes, right, all possible pairs that appear in my original list of dictionaries, I need to generate these tuples. And again, these tuples are the keys in this new output dictionary. So, right, a dictionary is defined by its keys and values. The values are list of dictionaries. Right? What do I want to do? Well, I want to find, right, so these are my original input right here are all my prescriptions, or my join data where I have joined the postcode. So I want to find all of these dictionaries here, say, that have this drug name and this postcode combination. And I'm going to put them in this list, which is going to be the value associated with this key. And I want to, repeat this for this combination of drug name and postcode, right? I want to find all of these prescriptions, put those prescriptions into a list, and that will be the value associated with this key in this dictionary. I hope this is helping somewhat to explain. So let's load this information. Oops, why is this my kernel died? I might need to close down some of my other pages here. I don't have a whole lot of memory in which to run. Let's close down that one. Let's close down that one. That's better. So again, it's come down here to where I was defining this. Right, a function here, yeah. So the idea here, like I look at this example, we say we want to group things by BNF name and let's go for the value of items. So what we want to do, this is the idea, we want to iterate over all the scripts. I want to find what is the BNF name and the number of items for that pair. And I want to construct a tuple So this is what we're doing here. Right, we're taking the field, right? So we're taking item of BNF name and item of items. This is, let's change my item. So this is scripts. Let's call this scripts. Right, I'm iterating over my prescriptions and I'm saying, well, get the BNF name and the items. This is what this portion is doing here. Create a tuple for each possible, pair that I encounter. These are the keys that I want to use in my dictionary. Right, so this drug was prescribed, and the items have said, well, this was prescribed basically with 2 refills. This was prescribed with 73 refills. This item was prescribed with 8 refills, and so on. Right now, I want to construct a dictionary where these tuples are the keys in my dictionary. I'm initializing a dictionary right here. So I'm iterating over these keys. I have now a dictionary where I have each one of these tuples is a key. And I'm initializing an empty list. So I initialize a dictionary. Now my groups looks like this dictionary. It's a dictionary, so I have this key associated with this value, which is an empty list. I have this key, which is associated with this value, which is an empty list. Now I want to fill up these lists. I want to find all prescriptions that have this combination of this drug name and this number for items, and I want to put those prescriptions into this list. And that's what this for loop here is doing, right? I take this element, which is in my scripts. I create the tuple, which is the key, by getting these values out of this dictionary. So I construct the key, and then I append this dictionary to this group. And this may crash my kernel by printing out this information. Right, here is one key value pair in my resulting dictionary. Right, groups, remember, is a dictionary. This is my key. My key is this tuple. The first string is the name of drug. The second one is corresponding to items that were prescribed. This portion right here is the value associated with the key in this group's dictionary. This is a list. This is a list of dictionaries. In this case, there are 2 items in this list. There's one item here, and there's one here. You'll note each of these 2 dictionaries has this drug name as its BNF, and it has 2 for the number of items. right? This is this here. I mean, this is another key value pair. So this key is this tuple. The value is a list. It's a list of dictionaries. There's only one element in this list. Here is another, here's another key value pair in this dictionary. It's a bit too long to fit on one screen because there's several items in the list. Right? We have this tuple as a key, which is again a drug name items combination. The value is a list. It's a list of prescriptions. Every prescription here in this list has this drug name. This Relvar, Ellipta, Inha, blah, blah, blah. Every dictionary in this list has items equal to 8. So this is what my output looks like. My output, remember, is a dictionary. The keys in this dictionary are tuples. Because of what I started with, right, my tuples are tuples of this form that has a drug name and an integer, which is the number of items that were prescribed in that particular prescription. The values are a list. It just so happens it's a list of dictionaries. And right, that's the idea here, is that, yeah, we want to construct these tuples, so things like BNF, postcode. We can't do that now because we haven't joined the postcode to these prescriptions. Right, and yeah, we have to construct all of these like tuples ourselves here. By iterating over these fields, and when I want to add an item to the list in the dictionary, well, again, I have to construct the appropriate key to find that key to append this prescription to this list. So good. And, right, I was just wrapping up this functionality inside this group by field method. So we create the keys, and then we initialize the dictionary keys. Each key has an empty list, and then we just iterate over and append and, right, return this group. So yeah, as we said, just wrapping up this methods that we did into a function so that I could call this. So this groups here, this will give us a group where these are tuples of one element. The comma in here is important. The comma says this is a tuple with one item in it. This is where I might crash my kernel again here because we don't have a whole lot of memory in which to work. So, we have a BNF name like folic acid tab 5 milligrams. So again, what is Yeah, my group by field is very, very big. That was a mistake to print it out. Groups is group by field. That's not printed out. Right, so this is a dictionary. If I say groups of a tuple with one value in it, well, I get all the groups. Right, so this tuple of one value, I get all the prescriptions that had folic acid tab 5 milligrams in it. So this is a list. It's a list. I could treat it like a list. What is the length of this list? There's 406 prescriptions for folic acid tab 5 milligrams. So any other questions for me today that I could try to clear up? I said I'm not going to start the DW mini project until next week. This is basically to give, everybody a chance to kind of catch up, go through the notebooks about pandas. Because the DW mini project is about using pandas to do data manipulation. Pandas is my data manipulation tool of choice. I was using it just yesterday. I had some personal information about my finances. A bit of this information is missing. I have to fill it in. Sometimes to test my def functions, I wish I could feed the function with fewer arguments to chew. Well, you can. I mean, for example, right, like you don't have to feed the entire scripts. Just take the first, 100 scripts, for example. Right, scripts is a list. Well, chop off the first 100 items. You may not get very long lists in your, in your results, but hey, it's a way of checking that the format, is what you are expecting. Right, so something like, scripts, scripts is a list. Well, keep only the first, 50, 100 items, etc. to check. Check that your function is working correctly. Although I'm not sure if that's what you mean by fewer arguments. All right, I'm going to leave things there for today. We've reached the top of the hour, so yep, think about your questions that you're having. Bring your questions tomorrow, and I will see you tomorrow. So have a good night, day, morning, whatever it may be where you are, and I will see you all tomorrow.